Hello students, and welcome to Series 2 of the Quarantine Lectures, where we talk about materials engineering. Hello students, and welcome back. So I want to kick off our lecture series of material science and engineering by actually doing something that my old college professor used to do. He later became my advisor and is now my friend, but he would always start off the materials class by looking at this. This is silly putty, right? Comes in the little egg at birthday parties like you're used to. And silly putty is very fascinating from a material standpoint, and it actually can help us understand a lot of the material properties that we'll be talking about through this entire lecture series, right? So what I've been able to do is, it comes in, we can form it, we can bend it, we can shape it as we want. But if we look at it, what happens if I slowly pull? It'll elongate and it becomes thinner, of course, and eventually it'll start to bend, it starts to go under its own weight, and we talked about that a bit with like bridges and stuff like that, okay? But we can also, if we reform it, similarly back to where we had it before. And now instead of going slowly, right, so we have the same thing we had before, but now instead of pulling it slowly, let's pull it quickly. And look what happens, right? It snaps. It gives us clean fracture lines just like that. Right, so now think about that. Why would that be different? Why could I elongate it, but then the rate at which I pulled it caused a difference in that material, right? So there's a lot of cool things that we can learn just by looking at silly putty. Again, it's this long. What you'll actually see is you'll see it elongate here. It's actually starting to pull itself apart under its own weight, right? You'll see it's getting longer and longer. I'm not doing anything to it, just falling apart on its own, right? There's a lot of really neat things that we can observe this with silly putty. So just with some 99%, just 99-cent thing you can get at the store. So, all right, so let's get into it. So what is a material? Materials are the backbone of everything, right? Everything is made from something, right? The laptop that you're watching me talk to you on right now is made of plastic and metal. Your car is made out of metal. Your home is made out of wood. And your concrete, or the driveway is made out of concrete, right? Your car has metal in it, right? Everything is made out of something. Now, I do want to note when when engineers and scientists talk about materials, most often they're talking about solid materials, right? There are gels, there are liquids, of course, which we've talked about. But the reason that we're focusing primarily on solid materials is because that's really what we make stuff out of. And what's cool about this field is that regardless of your discipline, right, regardless of what type of engineering field you go into, at some point you're going to encounter a materials engineering problem, right? Whether it be material selection, understanding the problem of materials, why is something breaking, why is the heat non-transferring as well, right? Those are all material selection and design issues. So material science and engineering is what we call this field. So material scientists are primarily concerned with understanding the structure of a material and how that relates to the properties. And materials engineers focus on the development of new materials or new processing methods on how we make these materials or the use in a specific application. And as we've talked about throughout this course, right, there are inherent differences between engineers and scientists, right? Scientists generally look for the why and how, and engineers are looking for the how we can use it to our advantage, right? Instead of the fundamental understanding, we want to know how we can use it. However, in material science and engineering, and of course there's a reason we call it that, material science and engineering, the why and the how are so inherently intertwined that both material scientists and materials engineers learn it the same way, and it's really the same field for both of them. And of course, that is why we call this field material science and engineering. Just keep that in mind as we go through this. So what we're going to be talking about in this series of lectures are really just the types of materials and the properties. There's a couple different types of materials, most of which you're already familiar with. There's metals and there are alloys. These are, metals like your kitchen knife, right? It's just a shiny metal. Examples would be aluminum, copper, and steel. We then have ceramics, right? The perfect example of a ceramic is like your piggy bank, right? You may have a piggy bank. You always saw in the cartoons or whatever, they'd smash it open to get the coins inside, right? That's a ceramic. clay pots, stuff like that. Your toilet seat. Toilets are made out of ceramics, right? The tiles in your bathroom or your kitchen are made out of ceramics. And examples there would be brick, glass, the glass in the window, glass is a ceramic, and rock. Then there are polymers, right? Polymers are everywhere in our life, right? First off, this silly putty, this is a polymer, right? These are long chain organic molecules that are made out of carbon, oxygen, hydrogen, and some other things, mostly just carbon and oxygen, but they're long chain organic molecules. Good examples would be cellulose, right? Polymers can be organic, right? They can be biopolymers. They can be rubber, be proteins, or of course plastics, right? Anything ranging from a hard plastic like in your computer or on your cell phone, or of course the crinkly type of plastics that are in a bag, or the kind of medium in between plastics that might be in a bottle. And the materials in each one of these groups possess different structures, which is what gives them their different properties. So fundamentals of material, I need to stop playing with the silly putty. Fundamentals of material science and engineering is we lay it out in this tetrahedron, right? So what fundamentally this field is the study of how synthesis, which is the way we make something, right? Processing, which is what we do to the material, the actual structure of that material, and then the properties of those materials are related. So what we mean by that is structure refers to the arrangement of the internal components. How are the atoms physically next to each other? How are the molecules attached to each other? Synthesis refers to the manner in which the material is made. Processing describes how a material is shaped or how it's treated, right? Sometimes we'll warm things up, do what's called annealing to try to get things in a better structure. And then finally, ultimately, are the properties. And this relates directly to the performance, right? We want to understand the properties of the material so that we can decide how we're going to use it, right? And those all relate to, in this tetrahedron here, we have synthesis and processing, structure and properties form the base, and are all integrally related to the performance of that material. Okay, so that's what we're going to be focusing on through this next set of lectures, is material science and engineering.